Welcome back. Here are question 12, 13 and 14. Question 12. Find the equations of the lines perpendicular to the line 2x minus 3y equal to 6 and passing through minus 2, minus 3. Find the equation of the line perpendicular to the line 2x minus 3y equal to 6 and passing through negative 2, negative 3. Number 13. Determine whether the lines with equations 4x minus 3y minus 12 equal to 0 and 8x minus 6y equal to 36 are parallel. Number 14. Determine whether the lines with equations 4x minus 3y minus 12 equal to 0 and 6x minus 8y equal to 36 are parallel. Alright, you can stop the DVD and try them and then come back for the review. So stop the DVD and come back for the review. Alright, let's look at number 12. Now you are given line 1. 2x minus 3y equal to 6. Find the equation of a line that's perpendicular to the above line and this line passes through that. You're given that. Now that is not in standard form. So step 1. Alright. Now I'm not going to write step 1. I'm just going to do it. So step 1 is I've got to bring this to standard form. So I will say minus 3y is equal to minus 2x plus 6. So y is equal to, I'm going to divide by minus 3 here. When I divide by minus 3 here, it will become plus 2/3 x. When I divide 6 by minus 3, I'll get minus 2. Alright, so I have brought that to standard form. Since it's perpendicular, the gradient of line 2, the gradient of the perpendicular line, will be the inverse of this, 3 over 2, inverse of this with a negative sign. Alright, so I'm just using the short way now. It will be the inverse of that, 2 over 3, it will be 3 over 2, opposite sign, negative. Alright, so we got the, now the next thing is we want to find C. So we take y is equal to mx plus c, and in this we're going to put m equal to negative 3 over 2, and we're going to take the points negative 2, negative 3, that will be x, that will be y. Now, when we're substituting y is negative 3, m is negative 3 over negative 2, negative 3 over 2 into x, which is negative 2, x which is negative 2 plus c. Then I'm left with negative 3 is equal to, now negative times negative will be positive, the 2's will cancel, put in your calculator, you'll be left with 3, no, you'll be left with, yes, 3 plus c. Now c is equal to negative 3, c is equal to negative 6. You can write like that, or you can say c is equal to negative 6. Right. Now, what I'm going to show you here is I'm going to show you a mistake that students always make. So, I'm going to redo this from here. See, from this step here, you got minus 3 plus minus 3 is equal to 3 plus c. Now many students, because they're solving for c, they'll bring the c here, which is fine. If you bring the c here, remember it will become minus c. That 3 remains there, so it's 3. This 3 when it goes across becomes plus 3. So you got minus 3 is equal to 6. Minus c is equal to 6. Then that's not c. That's minus c is equal to c, 6. So if you multiply both sides by minus 1, multiply both sides by minus 1 to get the final answer, c is equal to negative 6. So remember, if you bring in the c across, be careful that c will become negative, right? Whereas in this working the c remains, positive. Alright, whichever way you do it, you'll still get the same answer. C is equal to negative 6. And then finally your answer, y is equal to mx plus c. Just substitute only m. M is minus 3 over 2 x plus minus 6. And that final answer will be y is equal to minus 3 over 2x minus 6. So that's your final answer. Right. Now, some of you all might get minus 1,5 because using the calculator. So some of you may end up with the answer y is equal to minus 1,5x minus 6. That's fine. It could be common fractions or decimal. Alright, a few seconds to have a look at that, and then we'll move on to number 13. Now, number 13, you read the question and analyze it. It says, determine whether these lines are parallel. Determine, that's one line, that's another line. Determine whether they are parallel. Well, you cannot see whether they are parallel when they're like that, because they're not in standard form. So you take each line and you bring it to standard form. So you got 4x minus 3y minus 12 is equal to 0. So you bring it to standard form. Minus 3y is equal to minus 4x plus 12. Y is equal to, you're going to divide by negative 3 here. You're going to divide by negative 3 here, so it will become positive. So it's 4 over 3x. 12 divided by negative 3 will give you negative 4. So that's equation, let's call it line 1. So we brought line 1 to standard form, and we get y is equal to 4 over 3x minus 4. Then let's do line 2. Let's take line 2. 8x minus 6y is equal to 36. We're going to bring this to standard form. Minus 6y is equal to minus 8x plus 36. Y is equal to, I'm going to divide by negative 6 here, I'll get y. Divide by negative 6 here, so I'll just do this one step by step. Negative, I'm dividing by, so y is equal to, now negative divided by positive, you put 8 over 6 into your calculator, and your calculator will give you 4 over 3. You put negative 8 over negative 6 into your calculator, you get 4 over 3x minus 6. Now we're comparing line 1 to line 2. To determine whether they are parallel, we have to look at the gradients. So if we look at the gradient here, it's 4 over 3. If you look at the gradient here, it's 4 over 3. The gradients are the same. So, gradients are same. Or you can use the word equal. Gradients are equal. Therefore, line 1 is parallel to line 2. Alright, so you have to bring it to standard form, bring it to standard form, bring to standard form, bring to standard form, then compare the gradients. If the gradients are the same or equal, then the lines are parallel. If the gradients are not the same, then the lines are not parallel. But in this case, the gradients are the same, therefore the lines are parallel. Alright, so that was number 13, and we'll move on to number 14. Now, number 14 is a similar kind of question. We've got to determine whether the two lines are parallel. So, in number 14, we are given 4x minus 3y minus 12 is equal to 0. 4x minus 3y minus 12 is equal to 0. And we are given 6x. We are given 6x minus 8y is equal to 36. And we want to know whether the lines are parallel. We want to know whether the lines are parallel. Once again, bring to standard form. So, minus 3y is equal to minus 4x plus 12. So we can divide straight away. Y is equal to, divide by negative 3 here. Divide by negative 3 here, you'll get 4 over 3x. Divide by negative 3 here, you'll get negative 4. So, that one has been brought to standard form. Now let's bring the next one to standard form. And we can just call this line 1. We can call this line 2. Now this to standard form will be minus 8y is equal to negative 6x plus 36. Now we can divide. We're dividing by negative 8, so that will be y. If you divide negative 6 by negative 8, I'll just do it step by step. And then you got plus 36 divided by negative 8. So you'll get y. You put that in your calculator and you'll get 3/4 x minus 4, 5. You put that in your calculator. So you got 3/4 x minus 4 over 5. Both are now in standard form. Now you compare the gradients. You compare the gradients. This gradient here, m is equal to 4 over 3. But this gradient here is 3 over 4. Now they're not the same, right? They're not the same. So, gradients are not the same. So you will say gradients not same. Therefore, lines not parallel. Therefore, lines not parallel. Alright, that was number 14. Right, we'll move on to a few more questions. In this exercise, we have 31 questions, but they cover all the various aspects of interpreting straight lines. And once you do this, it becomes a foundation for interpreting parabolas, etc. in the future. Alright, so let's move on to number 15 onwards.